So this is video number 6 in a series of 9 to help you with the numbers patterns questions. Now let's have a look at this pattern. The first term is 3, the second term is 4, the third term is 6, the fourth term is 9. It's not an arithmetic sequence because it's not going up by the same fixed amount every time. It's not a geometric sequence because you're not multiplying by the same amount every time to get from one term to the next. So 4 divided by 3 isn't the same as 9 divided by 6. So you're not multiplying this by the same thing every time. So there's a very good chance it's going to be a quadratic sequence. So let's just have a look at the differences between the terms. So it's going +1, +2, +3. So the differences between the differences are going +1, +1. So those are called the second differences. And we can write as a pattern in words the second difference between terms is constantly 1. Between terms is constant, always 1. In very bad handwriting. Hopefully yours is better. So the fact of the second differences being constant is the thing that tells you it's going to be a quadratic rule. So something with n squared. Now, if the rule was just n squared, then we'd be getting 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. And the differences between those would go 3, 5, 7, 9. And then the second differences would go 2, 2, 2, always 2. We only want the second differences to be 1. So let's try a half n squared as the rule, or in fact I think I'll do this in decimals. So 0.5 n squared as my rule. So if my rule was a half n squared, then I would get for the first one a half of 1 squared, which is 0.5. For the second one, a half of 2 squared, which is a half of 4, which is 2. For the third one, a half of 3 squared, which is 4.5. A half of 4 squared, half of 16, which is 8. And so on. And then I would get the differences between terms as being 1.5, 2.5, 3.5, and the second differences are 1 every time. So that gives us, just get rid of that. So that means we're fairly sure that our rule involves 0.5 n squared. So let's just think once again about what we get from 0.5 n squared. So 0.5 times 1 squared is 0.5. 0.5 times 2 squared is 2. 0.5 times 3 squared is 4.5. 0.5 times 4 squared is half times 16, which is 8. So that is giving us numbers with a second difference of 1 between them, but it's not the numbers we want, because we want to be getting 3, 4, 6, 9, and so on. So let's just have a look at how far off we are from what we want. So our potential rule is giving us 0.5 when we want to get a 3. So we're missing 2.5. Next one, we're getting a 2 when we want a 4. So we're missing a 2. Next one, we're getting 4.5 when we want a 6. So we're missing 1.5. And then the next one, we're missing 1. So we need to add something that's going to give us 2.5, 2, 1.5, and 1. And clearly there's a pattern to that. these numbers are going down by 0.5 every time. And that is in itself an arithmetic sequence. And the fact that they go down by 0.5 every time gives us a big clue that the rule for those involves minus 0.5 n. But if we work out minus 0.5 n, then we get minus 0.5 times 1 is minus 0.5. Minus 0.5 times 2 is minus 1. Minus 0.5 times 3 is minus 1.5. Minus 0.5 times 4 is minus 2. So if we combine those numbers with the first line that we got to get minus 0.5 n squared minus 0.5 n, so 0.5 together with minus 0.5 gives us 0. 2 together with minus 1 gives us 1. 4.5 together with minus 1.5 gives us 3. And 8 together with minus 2 gives us 6. So we're nearly getting the numbers that we want, but we're getting 0 when we want 3. We're getting 1 when we want 4. We're getting 3 when we want 6. Clearly we're 3 short every time. So if we just add 3 to all of those and make our rule 0.5 n squared minus 0.5 n plus 3, then that should do the trick. So, algebraic rule, t equals 0.5 n squared minus 0.5 n plus 3. Hopefully you won't get one as difficult as that. I've never seen one quite that bad in the exam, to be honest, but that's what your thinking should be. All of this here that I've done, I wouldn't be attempting to write that in the response box in the exam. I would be doing that in rough. Okay, well, let's just get rid of all of that. Delete and delete and delete. There we go. I haven't got another pattern in words. Well, first of all, let's try and fill in the table. So if these are going plus 1, plus 2, plus 3, I'd expect the next one to go plus 4, and then plus 5, and then plus 6, and then plus 7. So that's how I'm expecting the pattern to go, just filling in the table. And they're alternating between odd and even, so I could write t terms alternate between odd and even. Okay, now the testing and verifying. So when n equals 3, my rule says that t equals 0.5 times 3 squared minus 0.5 times 3 plus 3. I might want to put some brackets around the bits of these, although strictly speaking they're not necessary. So that's 0.5 times 9 minus 0.5 times 3 plus 3. So that's 4.5 minus 1.5 plus 3, which is 6. So when n equals 3, my rule says that t equals 6, and that matches the value in the table. So that's a relief. This matches the value in the table, and so on. And then verifying it is just doing the same thing, but for one of the values higher up in the table where you made a prediction as to what the value was going to be, and to check that your prediction agrees with the rule. So when n equals 7, my rule says that t equals 0.5 times 7 squared minus 0.5 times 7 plus 3, which is 0.5 times 49 minus 3.5 plus 3, which is 24.5 minus 3.5, so that makes 21, and then plus 3 makes 24, equals 24, and that's what we got in our prediction. So just finally make the comment, this matches the value that I predicted in my table, and then we should be good for the marks.